thank you to the organisers for inviting me to come along today. Great to be the last up, so I stand between you and your evening. I'll hopefully make this an enlightening 10 minutes. It's a great opportunity to talk to you, so thank you for staying on to be part of this. The theme of this whole event obviously is one eye on the stars, and that's certainly a theme that runs through some of my early life. As a child, I used to look to the stars and think about spaceships, travel, intergalactical experiences, and watch programs like Star Trek, and marvel at things like being able to teleport across space and time, or some of the things that happened inside their spaceship when it came to looking after the crew, and the way that they dealt with medical issues. And certainly I think some of those inspirations that were there in those early days when I was in the 70s growing up clearly stuck with me, and they were a real foundation for some of the technology I'm going to talk about today. I'm Richard Vincent. I'm the CEO and co-founder of a company called Fundamental VR, and we've looked at technology and how it can help in a small way in the medical sector. And we've created a platform called Fundamental Surgery, and I'm going to tell you a little bit about it today and how some of those technologies are evolving. It's a really important space, the application of technology to better patient experience, to better life expectancy, to improve the way we live our lives is a key area, and I'm really proud to be a small part of that. As we thought about our leap and how we would develop our business and our technology, we really thought about a fundamental problem, hence the name, and that was the way that people learn medicine, the way that surgery is taught, the way that you experience that learning curve, whether it's for the first time as a medical student or later in your career as a qualified professor of a particular surgical discipline. As you continue to learn, the process of learning hasn't really changed in 100 plus years. It still involves practicing on humans, and there's an enormous human cost to that. There's an enormous financial cost to that. And I guess that's the theme to a lot of the technology that we're working with. It's really all about acceleration that will flatten the learning curve. We're all about making it quicker, more effective, and simpler to acquire what are really complicated skills, knowledge, and capabilities. So let me talk a little bit about the technology that sits behind that. There are really three key areas to our technology and the platform that we've built. It all sits within that area of immersive tech, of virtual reality, and it's a fast-moving space. We use the term blended VR, and we use blended VR to deliver real precision skills transfer. It falls into kind of three areas really, and they're represented in the three images you can see here. In the middle, you've got what I hope most of you will recognize as kind of standard VR. You've probably experienced something quite like this. You can see the power and understand the capabilities of being immersed into that environment. And I'll talk a little bit more about that in a second. The second brings VR together with presence. So putting you together with people who are not physically with you, allowing you to do things that you wouldn't otherwise be able to do without extensive travel, etc. And that's really on the right-hand side there. We call it our multi-user capability. And then on the nearest to me, on the left-hand side, we have what we call Haptic VR. So this is the combination of virtual reality with the sense of touch, really sophisticated touch that allows you to feel a patient, a virtual patient who's not really there in the room with you, but to learn what it feels like to do a particular procedure on that patient. I'll unpack that a little bit more as we go on. Sitting at the core of the tech that we've been working on over the last 6 years is this capability to deliver that sense of touch I was just mentioning. Haptics. Now, haptics is a word that is known fairly well amongst us these days. You know, we all have watches and phones that have haptic responses, and they're fairly simple, binary, but very useful haptic responses. But the haptic arena is much, much bigger than that. And this chart is trying to illustrate that kind of journey. On the left-hand side, you can see here some fairly basic haptic interactions, what we call cutaneous haptic reactions. So you're kind of feeling them on your skin. They're fairly basic, they're fairly binary, they're the buzz you get on a phone, or they're, in this case, the buzz you would get from a gaming controller that you might find with a VR headset. They can be really useful to let you know good and bad, to let you know when you reach a limit, to give you a warning or an affirmation of something good. And therefore we use them extensively for early stage development of knowledge and capability. But they undoubtedly top out, because what they don't deliver is the sense of force, weight, resistance, pressure, flow, any of those areas. And that's really where you go over to the other side of this spectrum, to something called kinesthetic haptics, which start to deliver all of those capabilities. And as you can see illustrated on this image here, you can deliver those kinesthetic haptics through lots of different devices, and I'll show you a few of those in a moment. Key point is we don't make any hardware devices at all. We simply ingest our tech, our software, into devices that exist in the market today. And like I said, we call that blended VR. So just unpacking it a little bit more into those three areas I touched on a moment ago. If we start with kind of the all-in-one device, you'll be familiar with this sort of device that you see here. This is, in this case, it's a Quest device made by Facebook, or Meta now. Great for scale, really cost effective. You know, you can acquire these for a few $100s. You can ship them very easily. You can achieve real scale and presence with these in terms of getting the hardware out there. They're great in the context of medical training, the area that we focus on, for kind of procedural understanding, looking at the steps of a medical procedure, or in my case, a surgical procedure. You know, you may have 200 steps within a particular procedure, and just going through the process of understanding the sequence of that is really important. Well, this is great to immerse you in there, to give you situational awareness, to allow you to stand and be and interact within a virtual operating room and go through those various steps. It builds your knowledge of those steps, it builds your confidence in performing those steps. But what it doesn't do is build the skill in actually delivering them. And that's where Haptic VR comes in. So here we still have scale. There's slightly more equipment involved. In the image you can see here, you can see an example of kind of haptics happening. They're using some grounded devices that provide force feedback. That whole system can go into a flight case that you could take as a carry-on. So really still very scalable, but undoubtedly more involved than the previous example. But what you get for that extra capability is real precision skills transfer, as I started to talk about. In this case, this one is in the field of ophthalmology. So we're talking about a real sub-millimeter precision procedure involving entering the eye, teaching ophthalmologists how to do that process before they ever get near a human being. It allows you to build competence up as well as that confidence I talked about. It really allows you to build up and repeat the procedure again and again to allow you to understand how that works. And because of the way we've built this haptic intelligence engine, whether we're delivering it into this hardware or indeed this hardware, is irrelevant to us. It's about what's the best capability for the job in hand. Now in this case, and I hope nobody's put off by some of the images here, in this particular case, you know, it's a hip replacement. And as part of that process, you have to feel the process of reaming the hip. You need to feel it smooth. The system can deliver that. You then need to feel it with your hand to check there's no any errors or any issues within there. This type of capability is really achievable with haptic gloves and with the haptic system that we use. Again, we don't make any of that hardware. We simply work with the best that's available in the market. And what it does is it delivers that real precision measurement, because we're measuring the position of your head, the position of your eyes, the decisions you're making, the positions of your hands, the flow of those hands. And these are all validated measures of surgical skill development. So they allow us to predict where you are today, where you're going to be in the future, how those skills are going to develop or not in some cases. So that's kind of two parts of the technology platform. The last part is in the area of collaboration, and we have a piece here we call Collaboration VR. And you can see it illustrated in the video here. Quite simply, let's collapse space and time. Let's bring people together in one space. You can see here about 50 students all in one location, sharing tools, sharing patient cases, sharing the operation itself, working as a team without ever leaving their location. It means that I can be taught by the world leader in a surgical procedure without that person ever having to travel to my location. It means that I can collaborate with teams from across the world simply by popping a headset on. Some of us might be using haptics because we're actually delivering the rehearsal, the procedure. Some might be observing and guiding and just wearing the at-home system. Really, really capable. All of it blended into that unique capability. So that's the platform, that's the way we work when it comes to using this technology to really move that needle forward and to make that next leap in capability acquisition, in skills acquisition across different markets. The key question I guess everyone probably has is, does it work? Does it make any difference? And the short answer to that is absolutely. There's been a number of validation studies conducted across a number of different markets. The first set of validation studies were virtual reality versus traditional training methods, which would involve video, presentations, didactic learning. Those studies showed somewhere between a 70 and a 240% improvement increase in the speed of knowledge acquisition. So a massive step up. So that's the at-home system I was talking about. No haptics, just learning the process. A massive step forward. Really good for medical students, really good for early stage residents within their surgical rotations. What these studies that are referenced here are talking about is the next step up. So if you take VR and then you add haptics to it, how much more improvement do you get on top of the improvement you've had so far? And the answer there is from some institutions that have run these studies, like NYU Langone over in New York and the NHS, the South Deanery in the southern part of London. The answer to that question about what extra up you get is somewhere between 30 and 44% improvement in the accuracy, in the skills transfer, in the speed of that skills acquisition. Really powerful. So that's the technology that we're trying to move forward on at the moment and applying it to this very specific and very needed use case, which is surgical training. Again, I emphasize not just for first early stage training, but actually all the way through a career of a surgeon. We have cases now where we are working with gene therapy and helping surgeons to acquire those skills before they go into the operating room. It's what I like to call pre-human competence. Learning on a virtual patient, having the perfect presentation of the case, having the imperfect presentation of the case, practicing it as many times as you want, in effect, swinging the bat until you get it perfect. It's certainly the way that we think surgical training will develop in the future, and I think it's a part of really all medical training over the next 20 years. Thank you very much.